Hello there, welcome to this Shieldia video guide on how to do the damn vulnerable web app command injection on low security from the red team perspective. The post is another combined post from all perspectives. However, the videos, depending on their length, may be separated out as we go. So let's jump right in. Hit up the blog at shieldia.co. You will then be presented with some of the preamble. There is an index of all of the other content. If you want to skip ahead, jump behind, do what you want. We have the prerequisites, which will bring up the lab. I'll bring this up every time. If you want to bring up the red team perspective, you're more than welcome. If you want to bring up the blue team perspective, which has all of the aspects of this blog post included, you're more than welcome, as long as your host meets the minimum system requirements. Today we will be looking at command injection, how this comes about in regards to the damn vulnerable web app, some of the specific shell meta characters within the Linux world. Don't GNU/Linux me, please. It's just Linux. We're all speaking the same language here. It's the purpose of it. We understand each other. I'm explaining that it's in essence as well remote code execution. So that would mean an attacker can execute code remotely from their perspective. So they'll be executed on your system. So whether that be a server, whether that be an IoT device, whether that be your IoT connected microwave, it doesn't really matter. They will be executing code on your system, which is not something you want, especially if it's in an unsandboxed environment. This is the sequence diagram of how these attacks may occur, especially with the damn vulnerable web app. Initially, it's the same preamble. You get the login, you get the tokens, all of that. Then we are going to be doing a loop in regards to the nuclei perspective. We would do a loop for the specific inputs within the post request. So the IP address, the escape character, and then the specific command we want injected, then an ampersand and submit because it's a post request. It will slowly loop through that until it finds ID because that's the command that we're using, is ID in the returned message body that it gets. If it succeeds, it'll see the value for UID. If it fails, it won't see anything. It will see just the ping attempt stats. You'll see as we go along. What we are going to then want to do is first log in to the damn vulnerable web app and view this page. We can then, through the Firefox instance of the Kali guest within the Tartarus lab, open up a session to damn vulnerable web app. We are going to then admin password. Don't show again, not now. Thank you very much. Command injection. We're also going to set the security to low. A key step. There are some that work on impossible, but that's neither here nor there. Not in this specific example, but in other places in the blog. Don't worry about it. Here we are presented with an input. Let us first have a look at, see if we can. It won't be able to ping this specific host within the Tartarus lab, but we can say, okay, enter an IP address, and then it will go and attempt to ping that IP address. There are some other subtle differences here, where it says ping an IP address, but we'll get there. So, okay, we see ping quad 1, which is Cloudflare's DNS resolver, failed because we're in the Tartarus lab and we don't allow ping to anywhere because it's a block by default. We get 4 packets transmitted, 0 received, 100% packet loss. This should look very familiar to you if you have used any Linux operating system. It is the default ping C4 quad 1. This will look exactly the same, which gives us a clue as to what the server may be executing in the background. Given the hint that it's command injection, it is most likely executing this command within a shell on the server. That then gives us some strings to pull on. Looking now at the blog post, that's what I've just explained. a brief side channel as to what meta characters are available if you suspect you have some form of command injection or remote code execution. One of the methods we have used throughout this blog is the pipe meta character. Here it is taking, it doesn't have to be a password file, it could be anything. So I believe we have the users file. Ooh, we don't want to do that again. We have the users file, should exist here. So we can do cat damn vulnerable web app users, and then the pipe symbol. We're then going to grep and then some value. So I know admin is within there. This then executes cat, which is, if you read the man page, says concatenate. It's used to join two text files together and then print the results to the screen. If it doesn't get two text files, it will concatenate the one text file with nothing and print it to the screen. So we can say cat and then that's just tab completion with the shell history within the specific bash or ZSH that they have within Kali. So you don't need to worry about that. But we're going to cat this, and then that's going to print it to the screen. The next step was grep. Grep is used to regex match specific text within a file or standard input. Here we're taking the standard output of cat, which here gets printed to the screen. With the pipe character, it will then get redirected to the standard input of the next command in the chain. We could do, well, when we run grep admin, it is then taking that standard input, which are these values, and then doing a grep for a specific string, the string being admin. Then that result is printed to the terminal or to the CTY. So we can see we've successfully grepped admin from that file. That is one of the shell meta characters that are available to you. And then that's just explaining the blog post. If you're using grep, there is the very common, and it's a very common bashism where you go cat whatever file and then grep it, because you want to say, okay, no, there is data in the file. The more bashistic way that I'm calling it is grep the string that you're looking for, and then the file works exactly the same and is a bit more, again, bashistic. We can do grep for leet within that file, and then it's just done exactly what we did with the pipe characters, but doing it all within grep. This is how it's a more optimized way of doing things. Now that we understand we have the pipe as one meta character, we can introduce another meta character, which is the semicolon. This, instead of taking standard input and then piping it to, taking standard output and then piping it to standard input, it will instead execute these two commands essentially in parallel. They are completely independent of one another when they execute within the shell. Here, for example, we will take, and then we're going to be grepping the last command that we ran, which will be bang bang, and then that will substitute in the last command in the shell history. So like I explained before, sudo bang bang, if you ran a command that required sudo permissions, but you didn't pass the sudo command first. Here, because the last command I ran in the shell history was this command, and this is basically what I wanted to input, you can then just use the bang bang command within the execution of an entire command like this. Here we can see echo, look, I'm on TV, then the semicolon, and then we're going to grep for that value within that file. So these two things happen independently of one another. We can see echo used to echo back at the screen whatever you input, look, I'm on TV, and then it's grepped for that specific string within the file. Moving on, these are the other meta characters. There's not an exhaustive list. There's one particular that's missing here, which is going to come into play with the Medium post of the command injection because there's some very interesting things we can do there. Instead, we have these meta characters. So the double pipe, as opposed to just the single pipe, the double ampersand. There is a single ampersand as well, which would basically background the job that you're trying to run. So for instance, I will do a systemctl status SSH, and then a single ampersand will background this. So now I can do an FG for that job, and then now that's brought that job forward to the terminal. So this is one way you can do some, this is more advanced topic, but one way you can do some job control as opposed to using something like screen or tmux. This is another implementation you could do. So we're going to exit, and then we're going to go, I believe it's jobs, and then there's no currently running jobs because I exited that job, as opposed to doing a, we'll do this again, but I will FG job 1, and then I will control Z, which then suspends that job. But that job still exists, so we can foreground it again if we wanted to. And now I'm just going to control C, which is going to cancel that job, and now it won't exist. Gone. So this is one of the meta characters, the ampersand. Then there is a double ampersand, which is if you have two commands that are running and you want one to succeed and then only execute the other, you'll use the double ampersand. Similarly, the pipe, if the first command fails, then run the second command, but only if the first command fails. The shell is able to interpret these things due to the status codes that it receives from the particular applications. For example, cat damn web app users, then I will double pipe echo hi. Hi didn't echo to the screen. Why didn't it echo to the screen? Because it's the double pipe. Here, instead, we'll do the double ampersand, and it will echo to the screen at the bottom there. Hi. If we said cat ASDF a file that doesn't exist, and then went with the double pipe echo hi, it's got an error status code, the shell has, and then it's gone, okay, well, the double pipe, so therefore we must execute the other part of the command. So now we can see hi has been successfully echoed to the screen. Then there are the redirection operators. So the single less than would redirect the standard output of a command to a text file. For instance, we have this text file that we were looking at today being the damn web app users file that we created earlier. We can then redirect this standard output to another file, asdf.txt, for instance. Nothing's echoed to the terminal, but you will see a new file, asdf, and if you cat that, the contents of that file, it will be the contents of the other file. If we were to run this again with a single redirect operator, it will just put that data into the file again. However, if we do a double redirect, it will append the contents to the end of the file. So again, this is just the Vim key bindings where it looks like here, but on your keyboard, it'll be the up arrow to move up the history, the down arrow to move down the history. We're going to cat it again, and now it's the file twice because we've taken the standard output from cat and then put that into the file and appended it at the end of the file. Finally, there's this redirect operator, which redirects from there's a trick you do with cat where you redirect the output into cat, and then you could do the EOF thing. It's done within the Tartarus lab deployment script. I'm not going to worry about that too much. Then there is the shell execution substitution command with the $sign and then open close parentheses. Whatever happens in that subshell will then become a value that you're going to assign, for instance, to a variable, like we do with the PHP session ID assignment. There is another one, the backticks, which isn't covered here, but will be covered in the medium post, like the medium security level post, where we can do some interesting things with how ping acts on localhost. Very interesting stuff, but it'll come later. Here we're going to use this to instead do something else. Brief aside over, we can now look at these meta characters and how it may be interpreted by our command injection. So we have, let's say we want to ping 127 dot, it's the whole /8, so don't worry, it doesn't have to be the .0.0.1, doesn't matter. Now we can say we'll redirect that output and then ID. So it's going to successfully do the ping 4 attempts, and then it's going to redirect that output to ID. ID doesn't understand that, so it's just going to drop it and then actually just output the contents of ID to our session here. We can do ASDF. ASDF will fail, and we say, oh, we don't get any returned data. So instead we can say ASDF and then our double pipe, because we know it's going to fail, and ID. Now we get the return data. Similarly, we can do 127.1.1.1 and then the double ampersand, because this is going to succeed, and then we get ID. Now this will print both things to the screen, the results from the ping and our specific user ID. Now this means we are executing these commands on the server. The www data user is the default user for file permission settings that Apache uses, so it can essentially correlate all of the file permissions that the web server should have access to. We can then do other things. You can implement a ASDF, our double pipe, and then a cat as well. You'll note I'm not putting spaces between these things because it's not strictly necessary to do spaces between meta characters in the sense. They are logically equivalent. Doing something like ls, and then, another very common one is using ps and then running an aux. These are logically equivalent. If I did it with a space and then did grep for a process like SSH, there's the one way of doing it, but it's logically equivalent to remove those spaces and then it'll run like that. It's exactly the same, doesn't matter. So here you'll note I'm not putting spaces between them. Comes into play a bit later, but don't worry. We'll do an ASDF double pipe cat etc password. This will then print, so the command fails, we don't get the output from ping, but since we're using the double pipe, we get the contents of that file. etc password, we'll explain a bit more why we can read this file in a little bit, but that is all of the users on the system. So there should be a www data user that we're running as at the moment. There should also be a vagrant user with the UID of 1000. Can I see vagrant? There we go. UID of 1000. So that's how vagrant provisions these things. You won't see that if you're running this on a hack the box, track me, all of that sort of stuff instance of the Damn Vulnerable Web App, but you will see it if you're using the Tartarus lab. So don't worry if you do see something that is not there in your specific instance. Moving on, these are the most promising candidates that we can use. So the double ampersand, the double pipe, and then the command substitution. We will explain this. We're going to now do a way that we can confirm that one way we can confirm the command substitution or the command sub shell is working. The way that what I suspect is happening when the server runs these commands is it's going ping C4, because by default Linux will ping until you cancel the process, as opposed to Windows, which will do 4 ping attempts unless stipulated otherwise. It's then redirecting the output of any error. 2 in this instance is standard error, like standard output and standard input. There's another stream, standard error. It's going to send that to dev null. Dev null is just you throw whatever in there and it just disappear in essence. Then it's going to run our, let's say here, this would have been pinging 127.1.1.1.1. Here we want it then to actually run our little sub shell. The first thing we're going to want to do is to be able to bless Python, to be able to bind to privileged ports within Linux. Any port between 1 and 1024 are considered privileged ports, and you need root level permissions to be able to bind to those ports. However, we don't want to give Python root level permissions over everything. So you can do something called a capability. We can set the capability to bind to privileged ports to Python. These are some other variables. So these are also doing some command substitution. The first thing is going to look for where the path, like the Python 3, it will run and bring the path for that specific file. Then we're going to say the real path for that, just in case it's a symlink, because you cannot set capabilities on symlinks. This is we're in the weeds here, but you can't set capabilities on symlinks. It has to be the actual file. So then we specify the real path of that file, which will reveal, if it's a symlink, where that symlink actually resides. Apologies, this should be outside of that. So that it isn't a symlink in this case, which is great, and it resides there in the user bin Python 3.3. That would be the binary that gets executed when you run Python 3, for instance. Now we will be in the interpreter, which we can exit, and we don't need to worry about that. Now, that aside, we will bless it with the capability to bind to privileged ports. We can then start, this is a very common technique within CTF challenges. You can use Python to serve local files on your Kali instance. Essentially, you're running it as an impromptu web server. We can then use this command. It's changed a bit since initially run, but for now, this is what will work. We'll call Python, and then we're going to call a specific module. That module being http.server. It used to be simple HTTP server. However, they've changed the name now to http.server. We're going to then serve port 443. Why are we serving this on port 443? Because I know in the firewall for OpenSense that that's the only port that has communication globally. If we tried to do the default like 9000 or 8000 or 8080, there is no communication between our target server and Kali on those particular ports. However, there is communication on port 443 and 80. So we will then listen on port 443 for any incoming connections and then serve the directory that we ran Python 3 from as a website. We can confirm this by going to localhost on port 443. Now we're serving that directory as a web server. You can look at specific files in here if you wanted to. So for instance, we will take, what's a good file to look at quickly? The ASDF file that we created earlier. So now it's serving that text file as a file over the web. All that to say, we are now listening for incoming connections. We can see here we have made this first connection, so I'm going to actually clear the screen so it's a bit more clear. When we run the command, we can then confirm that we've made a GET request to our specific listening server. That is in essence what we're going to be running. Curl is how you'd interact with web URLs via the terminal. So there's wget, that is a package to easily download stuff. Curl has a similar option, but it's a flag that you have to specify. Curl would normally just reach out to a web page and then download it. For instance, we can say in a new terminal window, we could do curl operates is it can interactively fetch the contents of a web page via the terminal. For instance, we could curl shieldear.co https, and then this will bring the contents of the shieldear.co onto the terminal. Is one way we can do these things. Now, listening on our web server, we can run within the command injection, we can run this command. We're not actually telling it to do anything. We're not telling it to ping anything. We're not doing any other meta characters. We're just telling it to curl this web page, because the order of execution matters here, that the subshell always will execute first, no matter what. And then the rest of the command will execute. So we just need to pass it this command. I know this is the IP address within the Tartarus lab of my Kali instance, and then the port that we're going to reach out to is port 443, which is what we're listening on. So we can look here and then doing some window manipulation so that they're both visible at the same time. And actually we're going to start again and then submit. There we go. So we can see a GET request from the source IP address, like I explained previously how these server logs would be formatted. We can see a GET from that source IP address, then the stuff that we can just ignore, those two hyphens, the timestamp, the specific method, the HTTP method that it's going to use. It's in quotes because it's user supplied. The response code, and then if this was a proper Apache logging, it will have the user agent, because curl has a special user agent itself. But because it's just Python, it doesn't have that level of logging, but it's using something very similar to the Apache logs that we looked at previously. So we can see we've successfully made a connection. So we didn't input anything else into the terminal, just that subshell. That subshell got executed, made a connection out to our Kali instance, and then the rest of the command completed. But we don't care. We don't care. It's gonna fail, but we don't care because we've already made that connection. Moving to something a bit more advanced, we can then use that to generate and do a reverse shell or rev shells. The revshells.com, really great resource, really, really powerful. We can then use that to create these rev shells. First, however, we're also going to bless Netcat or NC with the ability to bind to privileged ports. We can do that like we did before with that command. So we no longer need to serve here, but we're going to then allow Netcat to, without sudo, bind to privileged ports, or without root level permissions. We can then do an NC for the specific port. So NC NVLP for port 443, so we can listen for any incoming connections on that port. I'm going to clear the screen so that it's a bit more visually clear what's going on. NC NVLP for port 443, listening on any for that. If we want to confirm these things, we can open up a new window and then look at ssnutlp. This will give us a list of all of the open web sockets, TCP or UDP, on the host at any given time, or in this case, the guest, the Kali guest. So we're listening on port 22 SSH. Then we're also listening on port AS11-44-6549, which is what we're doing now. Now, here it doesn't give us any information as to which process is running this, so you have to run it with sudo to be able to get which process information. So sudo, and then, because I'm lazy, I do sudo bang bang space, and then that will run the previous command with sudo permissions. And you can see here, it would be nc or netcat and that specific process ID, listening on that port. Great, so it does work, which is good. Always good to check these things if you have to debug them. Now we're going to, with a rev shell from rev shells, do that connection. See here, it is again with the command substitution. We know PHP is installed on the server, so we're going to use one of the PHP rev shells. We're not going to use the full file-based rev shell. Instead, we're going to use one that's just by the command line. It's going to do open a socket to this specific IP address on the specific port, and then it's going to execute sh, which is the normal shell executor. So it was originally shell and then the born again shell bash. It's going to execute sh and then do some redirection for the specific standard inputs, standard outputs, and stuff. So you can run that on the web server. Run that there. Boom. We can see now we have successfully caught that reverse shell. So from the Dan Von web app, we're now connected via a terminal on our Kali instance. Of course, this would happen probably via another mechanism if they're going to do proper reverse shells and stuff. However, for these examples, this is how we're connecting. You can then do an ls, and then because we're doing it with just simple sh shell, we don't have access to a lot of the other fancy stuff, but simple commands like ls for listing the directory, cd for changing the directory, all of that work just fine within the normal shell. If you want to upgrade that shell, there is a command I will attribute to Robnop, because that's the first blog I saw. Unfortunately, I think it's been taken down, so this is just a Wayback Machine link to his or her blog where I originally found this. If it's not that specific individual, my apologies, but that's where I found this, how you can use Python to be able to spawn a bit more of a shell-like existence on the server. This is a bit louder because now we're running Python, there's other dependencies that are going to happen. Within a CTF, this is great. Within an engagement, maybe not. It depends if Python is even on the server. You could package a binary and then just run it like that if you really wanted to be sneaky beaky. But for now, we know Python, through some magic, is already installed on the server. We can then run this. I've altered their command slightly, what they would advise in their post. We're doing again the real path for Python, and then we're doing a command, so a real path for Python v3, not Python v2, and then we're saying a command import the pty and then pty.spawn a bash session. So now there are some bashisms that you can do within this specific shell. For instance, one of the ways bash would inform you of which user you are and then at which host you're at, which, like you could see here, which user I am and then on which host. And then there are other bashisms you can use. We're not going to go deep into the weeds of what you can do in terms of actually enumerating this box once you have a reverse shell, because you can do basically anything. Once you're on the machine, you would then want to probably escape from that constrained WWW data user to a privileged user. We're not going to go into that in this specific guide. This was merely a demonstration to the fact that we can also do it via the command subshell, the $ open and close parentheses. That also works. Moving on, we have curl, everyone's favorite. We can do all of the commands that we did previously via curl. This is very useful if you want to start scripting some of the ways and means that you're interacting with the target server. Here we're doing, again, like we've explained, the this subshell will execute, and then the results of that subshell will then become the value of this variable within the bash instance and within the bash window. It doesn't persist because we're not using like export or anything like that, or the env, like system env. We're just doing for that specific shell window, that shell instance, this variable will equal the login prompt, and it will equal the PHP session ID that we spoke about before. So here, for instance, that's just an example of the output. Then it does ping because it's a HTML. Curl is not going to like render it like a browser would. It's just going to output the HTML to the terminal, and then you can go through and read, yes, it has, in this case, successfully executed the command, but the command has failed because the IP address 10.10.10 doesn't actually exist. If you wanted to try it yourself, then you could do it with the, so with this field, we're specifying the parameters that would be input if you were to do this via a browser, via the post request method. These would form the data within that post request method. To illustrate that, we can just do a wait. To illustrate that, we'll do inspect element and then look at the network tab, and then we can do a ASDF cat etc password. So now within this post request, within the request, you can see how I derived these values. It's going IP, ASDF, and then that. And in this one really got me. It has to be URL safe. I wasn't aware that it has to also be URL safe. So it's not just what you interact with via a URL. The data in a post, or the data in a post request also has to be URL safe, which is quite fascinating to find out. Then there's another variable, which is the submit equals submit. All that to say, that's where these values come from. Moving on to fuzz foster you fool. So how you would find these vulnerabilities out there in the wild. We're going to, instead of doing the 3 commands in one, we're going to do them each individually. We're going to close this, clear that, move myself, we'll move the window over there. So this, again, uses the PHP session ID to fill this variable. So we could echo that if we wanted to. Echo PHP session ID, and then that's a valid session for this specific time window. We will then do, so you have to have, oh no, this isn't a custom one, this is a second. So this should be default, the wfuzz. What we're doing with this is, because this is another thing that I had to find out how ping works, I could say ping C4, and then I could just ping like a number, and it will convert that number to an IP address. We don't want that. So don't engage with this specific IP address. This is outside of the scope of this video. This is just by way of example that ping will convert whatever numbers you put in into an IP address. Please do not engage with it. So we have to remove all the lines that are just numbers. So that's what the sed is doing. It's going sed, then 0 to 9, delete. So any regex that matches that, 0 to 9, delete it. If it's in a line, just bye. For that specific word list, now that then gets, like I said previously, redirected to the file attack.txt. So now I can cat, and then again a bang, and then $. This will expand to the last argument of the previous command. So, and wait, and $, then it expands to attack, because that's the last argument of the previous command. Instead of going and typing attack because I'm lazy. So here we can see this word list without any lines that are just numbers, because we don't actually want ping to ping those and resolve them and waste my time. We can then finally run the fuzzfasterufull command. So I'm going to clear the screen for that. So fuzzfasterufull, we're specifying like you would with curl, we're specifying an X post. So that's the HTTP method that it must use. We're being explicit here. You don't have to technically with curl be explicit like this, because it's able to interpret by the fact that you got a D. But because post and put are so similar, we just want to say, okay, post request these specific values later on that I'll show you. We're specifying the URL to be the damn vulnerable web app, the word list to be attack, which is what we just created, the security to be low, and then the PHP session ID to be what the PHP session ID variable is within the specific shell window. Then we're going to say the IP fuzz, we want to then fuzz that value. That value, fuzz is the default word list fuzzer for fuzzfasterufull. That then will be each line within attack will be substituted there. This is not perfect. Technically, it should go through a pen code and then make each one URL safe. Is what I would prefer, but for now it works, and it's able to list out commands that we could then run in the web server that may or may not work. So it's saying just that by itself should work, that by itself should work, that by itself should work, etc., etc. Then you can go and take these and then attempt them within the damn vulnerable web app. We know this because the status code is 200 and we're filtering a specific word amount in the response if it doesn't work. So these are the ways you slowly iterate through, and then you're able to come up with a combination of filters and match conditions to find what you are looking for. It's a bit of a trial and error. There's no one shot, oh, this is exactly the command that you would want to run. It's a bit of a trial and error. So for instance, we can try this command and see if it works. We can just see if it works. Move that over there, do command injection, enter an IP address, and then that has successfully come back with a directory listing. So it's a Linux command, ls to list the directories, and then we're saying tac la to give us all of the, because by default it wouldn't show you any dot files. So any files that start with dot wouldn't, this is a long story. Anyway, that's neither here nor there. So that command works. We can then also attempt the dir command, again, Control-Shift-C to copy out of the terminal window, and then Control-V to paste. Dir also works. Then you can go through those commands and you can see, okay, so this is how, these are the meta characters that might be escaping the specific constraints of our enter an IP address text box. That is all for the red team perspective. In the next episode, we will go over the blue team perspective of how we might detect this activity that is happening on the server that really shouldn't be happening. Again, in the Medium post, we discuss some more ways and means to exfiltrate data out of the server using the backticks. It's very interesting, and like a local host stuff. Really interesting. You're going to want to stick around for that. That's all for this video. Thanks for joining me, and I will see you in the next one.